Hey everyone. So we recently had an issue with one of our clients. They were running on this process that we had talked them into last year where they have this batching Lambda. Its whole responsibility is to figure out what kind of items need to be processed as part of a nightly batch. And then it tosses a bunch of messages into an SQS queue. And then Lambdas subscribe to that queue and they go ahead and they process all those individual items. And everything was working really great for them. However, they came to us a little while ago and they said, well, how do we know when this process is done? And I thought that was a really interesting question. Now, there's been a bunch of articles that have talked about this before. The one that I ended up going to and reading was Jan's article on step functions specifically, but also how you could do this with a simple SQSQ and some Lambda functions. But, getting process changed over to using step functions wasn't really going to be very viable in this situation. And we had this problem where step functions at scale can be pretty costly. And we wanted to keep this really, really cheap because it had been cheap for them so far. So we set out and I looked through the article and it basically kind of had that sort of drawn owl kind of feeling to it, where it's like, okay, draw a circle, and then just draw the rest of the owl. So it talked about a Lambda function and a DynamoDB table, and you're done. And I felt like that just wasn't really quite enough detail. So I decided to dive into it a little bit, figure out what was going on. And in this video, I want to kind of walk through that solution, kind of hit the highlights of it, some of the struggles or challenges with it, and then talk about some alternatives for how to implement something like this in the future. So let's get started and take a look at it. Now, the first part of the process isn't changing from a lot of the standard talk that we've had in the past. You have a Lambda function. I call it the batcher. And this batcher is responsible for figuring out what items need to be processed in this batch. And then it's going to write those items into an SQS queue. So we've got the batcher. It writes these messages into a queue. And then you've got your processor Lambda function on the back end, which is responsible for processing each of these items. Now, the message that I write into the queues, there are going to be three kind of key pieces of information. One is a batch ID. One is an item ID, and the third is all the extra information you would need to know to actually process that item. Maybe you want to toss some things in there so that you don't have to go back to a database to kind of retrieve things. In the case of my example code in my POC, I randomly generate a value between 1 and 1,000. And in the processor, that value is used to simulate work by simply delaying the processing or doing a sleep for that amount of time. So the messages get written into the queue, the processor picks them up, processes each item. So the way that Dynamo kind of ties into this whole thing is through two main records that are going to be maintained by the processor. The first one is the batch state record, and the second one is an item state record. So I'm going to dive into each of those individually here. Now, I want to start with the item state record because it's sort of the more complicated of the two. Um, I did not want this solution to be restricted to using a FIFO queue with SQS, so I built it to be able to work with a standard queue. But because standard queues are 1+ deliveries, there were a lot of edge cases where I might receive an item twice, and I don't want that processing to happen twice on that item. Maybe it's sending an email where those downstream systems aren't idempotent by nature. So there's an item state record that I store and I write when I first start processing the message. There's a check that says, okay, go ahead and try to write this item state record based on the item ID and the batch ID. And if there's a record that's already there that's in a processing state, that's just an attribute on the item, well, then this item was a 1+ delivery, and let's go ahead and just skip it. If there's any other state on that item, if it is in an error state or a finished state or whatever, there's some sort of reprocessing going on here. So that's fine to go ahead and continue. So the item state record kind of holds that if there's a failure at any point processing that item, I typically will just toss that error message onto that item, makes it very easy to go back and figure out what was going wrong. And then everything goes through. Once the item is done processing, I mark it off as completed or finished. And then I tossed TTL on there because, I don't really need this record past a certain time, especially if it succeeded. So once it succeeds, go and leave it there for a little bit and then get rid of it. I think I set it up for an hour. You may want to set this up for, a day or 3 days or maybe a week, but you do want to get rid of that record. It doesn't really have a whole lot of value. Now, the batch state item, this one is really the key to this whole process and really the focus a lot of this work here. So the batch state tells me when all the items are complete. Now, originally, I wanted to write this so that when an item came in, it would go to that batch state record, which holds the batch ID. The sort key is going to be just the word status. And then there was a remaining field. That remaining tells me how many records still need to be processed. And everything downstream is going to eventually look for a remaining of 0 to tell me that the batch is done. Now, I really wanted it to be so that the batcher, the thing that starts the whole process off, it didn't need to be aware of how the downstream processing was going to work, but that didn't really work well because it means that the processor then is responsible for incrementing that batch state remaining field by 1 when a new item comes in. And then once it's done processing the item, reduce it by 1. But there were way too many edge cases where I could end up with a remaining of 0 while there were still items in process, in flux, those sorts of things. Maybe they just hadn't been picked up by any processors yet, therefore they hadn't incremented the value by 1. That's a really big problem. So the batcher is actually responsible for writing this initial batch state item. So if it knows that it has tossed 1,000 items to be processed, then it writes this batch state item to the DynamoDB table at the very beginning of the process saying there's 1,000 items to be processed. So then as each processor goes through and processes an item, it just decrements that count by 1. All right, now the fun stuff. So now once the entire batch is done, we know this, we can programmatically know this because that remaining is now 0 on that batch state item. And we can respond to that in a number of different ways. The way that I chose here, because I wanted to play around with event bridge pipes a little bit, is I set up event bridge pipe that sits there and monitors that stream, the DynamoDB table stream, for when that specific item has a remaining of 0. And then it goes ahead and publishes to EventBridge a message that just says, hey, this particular batch is done. And the way that I respond off of that EventBridge rule and the POC was just to execute a Lambda function, but I could do this any sort of which way I want to. This is just EventBridge work at this point. Whether you want to respond with a Lambda function, go to an SNS topic, whatever it may be, that's fine. However you want to respond to it. There's a couple of different ways I could have just gone straight from the DynamoDB stream straight to a Lambda function. But again, I kind of want to play around with event bridge pipes and show just a really nicely decoupled system along the way. But that's it. So in this batch processing, I can just throw tens, hundreds of thousands, millions of items into here. They'll all get processed. And then when it's all done, that DynamoDB table with a remaining of 0. And that's when I know my batch is done. And this is all designed out that you could even run multiple batches in parallel, and that would be fine. All right, so let's talk about variants because just because something works doesn't necessarily mean you're done working on it or that it is really the best way to get things done. So once I kind of had this worked out, I actually reached out to some fellow AWS heroes. And one in particular, Jeremy Daly, he sat down with me and we kind of worked through this. And he brought up a lot of really good points on some of the things that I'd done. And I want to share them with you because they don't necessarily change a lot about how this particular solution would work, but they're really good things to keep in mind if you want to build something like this in the future. So the first thing is that as I introduced the item state record to the DynamoDB table because I was trying to catch that item potency with SQS, then I actually kind of introduced 2 layers of persistent store into the system. SQS, which is persistent data, and then DynamoDB, which again is persistent data. And if you look at the code, there's actually some stuff that I had to do within the processing lambdas to make sure that those don't really get out of sync horribly. Great point that Jeremy brought up was I don't really need the queue at that point. One alternative is I could have the batcher write the batch state record and then all of the individual item state records. And then the processing Lambda is actually on the stream for the DynamoDB table. Now, this is going to reduce the amount of components within the system. I no longer have to worry about an SQS It does simplify things. This was a case where my particular solution here was specifically trying to work with SQS. So it wasn't going to really be a good refactoring or rework, but I thought it was a really interesting observation and something really worth considering in the future, which is you kind of already have a queuing mechanism that works really well. Now, a stream works a little bit different than a message queue, so you've got some edge cases there as far as if a message fails, how does it get reprocessed and things, but could be a really good alternative for you to try out. A different variant, a different way of handling this is that we could avoid the batch state item altogether if we simply used a GSI on the table that took a look at the item state records and determined from those item state records whether or not they were complete or not. So basically a GSI that's looking for item states that are in a finished state or not in a processing state and going off of that. Didn't really flesh this all out. GSIs can be kind of painful to work with. I don't do a whole lot of work with them, but certainly something worth digging into and figuring out how would a GSI in this situation work to avoid having to have this batch state record. You would have to introduce some other components into the system. For example, there would have to be some sort of polling mechanism. They would have to go and read this GSI to figure out whether or not the batch was done. And it felt like it was adding a lot of complexity that I didn't really want to do in a normal situation, but an interesting alternative. And finally, the third one is around the whole queue mechanism itself. So I said in the very beginning, I wanted to be able to use this with standard queues. However, if you were able to restrict yourself to a FIFO queue because maybe your throughput wasn't really as high as you want out of a standard queue, you could use a FIFO queue. And with a FIFO queue, you would largely ditch needing the item state record, which is primarily there as an item potency check. But additionally, you would get some really interesting concurrency controls by using a FIFO queue. So I don't know if you know this, but when you use a FIFO queue, you provide things like group IDs on the message to say these messages are contained within the same group and should be processed together. Now, when you subscribe a Lambda to a FIFO queue, the whole Lambda subsystem for getting messages out of the queue and handing them to your Lambda function will take this group ID into consideration and only process one set of messages out of each group at a time. So that might be a little confusing. Let me see if I can try to explain a little bit better. So let's say I have a group ID of A, and in group A, I put 1,000 messages into group A. Well, when the Lambda subsystems start reading messages off the queue and handing them to my Lambda function, it'll only take 10, up to 10 messages at a time out of group A and hand those over to the Lambda function. And then once those 10 are processed, then it'll grab the next 10 and the next 10. It'll do this 100 times if I have 1,000 messages. So if I want to make sure that I've got only, say, 10 Lambda invocations in parallel at one time, then I have 10 groups that I create out of the batcher process. And it is kind of a useful control for changing your concurrency and your parallelism without having to worry about the normal concurrency controls within Lambda functions. Because you can actually then make it so that concurrency and that parallelization is controlled at runtime rather than configuration time. So maybe a particular batch, you come across it and you go, well, I know that because of this time of day and this data and whatever, I want this batch to be really, really highly paralleled. So I'm going to create a bunch of groups and I'm going to have these things all running side by side and I'm going to eat up a bunch of my concurrency, but that's okay because I want it processed really, really fast. Great. But then you look at it and you go, well, this is maybe in the middle of the night and I'm not worried as much about the time, total time it takes to process the entire batch. So I'm going to create fewer groups, eat up less of my concurrency on my Lambda service, and therefore leave more concurrency open for other Lambda functions to run or whatever. So you get this really interesting mechanism to control that concurrency, and it was just a really interesting approach. Plus, again, if you do the group IDs, even if you don't worry about any of that, going with a FIFO queue means that you can simplify things by getting rid of effectively that item state record. If you have problems processing an item, you just have to go back to your logs then and alerts or things on that. So that's about it. Really interesting diving into the thing and really getting into it. Again, I'll post a link in the description to the sample code. If you've got questions about it or if anything hasn't been really clear, I'd love to hear about it. You can always hit me up on the GitHub with an issues there, or you can leave a comment here in the video. But hopefully this was valuable and you got something out of it. Hopefully more than just, toss a DynamoDB table in there and you're done. It really wasn't quite that simple in the end. So thank you very much. As always, if you find this content kind of useful and good, go ahead and like and subscribe, and it lets me know that I need to produce more of it. So thanks.